Good morning, students. In class 12th, we are going to discuss exercise number 1.3. This is lecture 3 for the class 12. So, earlier we had discussed the composition of function, invertible function, and types of function. So, all the things are completed. So, just we are going to discuss some questions based on and all these topics, especially on invertible function, which is important for board also. So just write. First you see question number 9 from exercise 1.3. Exercise 1.3, question number 9. This is most important. Okay. So as you know, for proving, that means to prove a given function is invertible function, we need to prove function is 1 1 and on 2, and otherwise, or second method, you can say f and g are two functions. If they are inverse of each other, then f composition g of x is x and g composition f of y is y. Okay, so see, f from r plus, question is already you have. So question number 9 from 1.3. Consider f from r plus to minus 5, r plus to minus 5, comma, infinite, given by fx is equals to 9x square plus 6x minus 5, so that f is invertible and with f inverse y is equal to root of y plus 6 minus 1 upon 3. So function is fx is equals to 9x square plus 6x minus 5. This is the function. And what? So that f is invertible with f inverse y is, with f inverse y is root of y plus 6 minus of 1 divided by 3. Okay, so as you know how to prove. So first of all, you see, given function is y is equals to fx is equals to 9x square plus 6x minus 5. 9x square plus 6x minus 5. This is the function. So you know x is equals to what? From this, if you see, x is equal to f inverse y. Okay. So y can be written as 9x square plus 6x minus 5. Okay. So y can be written as, you can represent x in terms of y, but it is not so easy. So first of all, see how to represent x in terms of y. For this, we must make it a complete square. So 3x whole square plus 2 into 3x into, supposed to be 1, then this is plus 1 square and 3x plus 1 whole square, and if 1 whole square this is, then this is minus of 6. Okay, because 1 minus 6, this is minus 5 only. So y is equal to 3x plus 1 whole square minus 6, if you see. Okay, so 3x plus 1 whole square is what? Y plus 6, and see here, okay, 3x plus 1 is the root of y plus 6, and x is, 3x is root of y plus 6 minus of 1. So x is nothing but root of y plus 6 minus 1 divided by 3. And you know very well, if y is equal to fx, then x is what? F inverse of y. So you can write it as f inverse of y is nothing but root of y plus 6 minus 1 divided by 3. This is inverse of the function. Okay. So we just going to discuss first method. That's why first we find the inverse of the function, and now afterwards we have to show f composition f inverse is equals to x and f inverse composition f is y. This is the first method. Otherwise you can show this function is 1 1 and onto, that is bijective, hence it is invertible. So note it down. Okay. Now, in order to show the given function is, in order to show given function is an invertible function, we need to show f inverse composition f composition of f inverse of x is x, and f inverse composition of f y is equals to y. Okay, so first we have to show this f composition of f inverse x, that means f inverse of fx according to definition of composition of function, and fx is, you know very well, what, 9x square plus 6x minus 5, and f inverse y supposed to be y, then f inverse y is what? This is nothing but f inverse, that means at the place of y this is 9x square plus 6x minus 5. You see the f inverse y, root of y minus plus 6 and minus 1 divided by 3. So this is nothing but 9x square plus 6x plus 1 minus 1 divided by 3, and you know very well this is 3x plus 1 minus 1 whole divided by 3. This is 1 1 cancel out, 3x by 3, and this is x only. See this one, 3x plus 1 whole square, that's why if it will comes from the square root, it is nothing but 3x plus 1 and minus 1. Okay, so cancelled out, 3x upon 3, this is x. Okay, so you saw here f inverse, f composition of f inverse x is nothing but x. So first thing is completed. In the same manner, the second, f inverse composition of fy is equals to y. Then we can say the given function is invertible. Okay, and this is the easiest method to find the function is to be invertible function. Okay, so note down. Okay, see the second one, f inverse composition of f y. This is nothing but f inverse composition f of y. This is nothing but f of f inverse y according to definition of composition of function, and f inverse y is nothing but f of root of y plus 6 minus 1 divided by 3. Okay, and this is fx, and x At the place of x, this thing. So fx is defined as 9x square, but x is this. So root of y plus 6 minus 1 whole square upon 3 3 is a 9. And then plus 6 into x. 6 of root of y minus 6 minus y plus 6 minus 1 divided by 3. Okay, and plus of minus of 5. And this is homework for you. You solve it and get as y. If you have any doubt, just I am going to explain you. 9 cancelled out, so only this thing. 3 2 is 6, 2 times this thing, and minus of 5. And if you square it, then this is y plus 6 plus 1 minus 2 times root of y plus 6, and this is nothing but 3 2 is so plus 2 times root of y plus 6 and minus of 2. So this thing is cancelled out, minus 2 1. So this is nothing but what? Y 6 minus 2 4 plus 1, y plus 1 minus 5, y plus 5 minus 5, and this is nothing but y. So what you saw here, F inverse composition. So F inverse composition, F of y is nothing but y, and hence it is an invertible function. Okay, so I hope you understand. Now we are going to discuss the second method. So first of all, you note it down, and then after second method. Okay, you may complete it. Now see, for the same question, second method to find the given function is an invertible function. Okay, so see, second method, given function is fx 9x square plus 6x minus 5. Okay, this is the function. We had to show this is an invertible function. So here we write, in order to show f is an invertible function, we need to show given function is one one and onto, that is bijective function. Bijective function. What we need to show? The given function is a bijective function. So for 1 1, for each x1 x2 belongs to whatever the r plus, okay, fx1 is equals to fx2. So we can write 9x1 square plus 6x1 and minus 5 is equals to 9x2 square plus 6x2 minus 5. Minus 5 cancel out. 9 x1 square minus x2 square and plus 6 of x1 minus x2. This must be 0. And we can see here x1 minus x2 is common in both. So this is 9 times x1 plus 9 times x2 plus 6 is equal to 0. As you know, this is not 0. So x1 minus x2 is what? 0. This implies x1 is equals to x2. So fx1 is equal to fx2. We had to show here x1 is equal to x2. So we can say the given function is 1 1 function. Now for onto, this is 1 1. Okay, so you may note it down. Now for onto, given y is equals to fx is equals to 9x square plus 6x minus 5. Again the same process. We can represent x in terms of y. X in terms of y. So y is equals to 9x square plus 6x minus 5. So x is nothing but y is equals to 3x whole square. 2 into 3x supposed to be 1 plus 1 minus 6. So y plus 6 is equals to 3x plus 1 whole square. So 3x plus 1 is equals to root of y plus 6. So 3x is equals to root of y plus 6 minus of 1. So x is equals to root of y plus 6 minus of 1 divided by 3. This is the completing square method, as you know in class 10th already. So x can be represented in the form of what? Y. And what is the definition of onto? For each x belongs to x, that means first set, we have to, there exists y belongs to y such that y is equals to fx. That means fx is equals to y. So this is what belongs to R plus. What is the domain of, first set, that means set A for the function. So x belongs to x, there exists y belongs to y. So y belongs to y, that means second set. What is the second set actually? Second set is minus 5 to infinite. Minus 5 to infinity. Okay. What? Y belongs to y such that fx, f of x, x is what? This root of y plus 6 minus 1 divided by 3. This is fx, and if you solve it, earlier I have already solved in last question on previous method only. So if you solve it, you will get, this is y. Why? Because 9x square, that means y plus 6 minus 1 whole square upon 9 plus 6x, that means 6 into root of y plus 6 minus 1 divided by 3 minus 5. If you solve it, this is nothing but y. So what do you get? Fx is equals to y. For what? For each x belongs to R plus, that means what is given the first set, there exists y belongs to y such that fx is what? Fx is nothing but y. So I hope you come enjoying this particular video and understand the question. This is the most important question and so many times asked in the board. And one more thing is there. Sometimes this particular question is asked in the manner, suppose all the things are same, like given function is same, you have to show the invertible, this is an invertible function, but in last one more particular question is added in this. What it is added? Suppose f inverse y is nothing but this. Suppose f inverse y, you find f inverse y, then f inverse y is nothing but y plus 6. Here f inverse y, this is nothing but root of y plus 6 minus 1 divided by 3. This is the value of f inverse y or x, whatever it is. Okay. So one more step is added. Also find f inverse 2, suppose, or f inverse 3, suppose f inverse 3. Okay. So how will you find? It's simple. F inverse 3 is what? root of 3 plus 6 minus 1 upon 3, root of 9 minus 1 upon 3, so 3 minus 1 upon 3, and this is nothing but 2 by 3. So one more step is added here. So you just solve. So please try to solve exercise. Some more questions we had to discuss in next lecture, and then we start binary operation, that means next topic. Okay, so thank you, be safe, and